Now, how about now? Wait, we should be saying something while we ask, "Can you hear us?" Maybe said no, so can't hear. I will say
Okay.
we
Can't hear. Oh God. No! Come on. Should be okay.
yes. She said Landon, yes. Someone said
What
they
about
can
me?
orange dot. The orange and dot symbol.
Yeah, yeah,
Says
orange
Landon,
dot.
yes.
What about both now? Is it both are you can hear both
Maanyaa?
of us?
Testing.
Oh, brilliant.
Testing. 1, 2,
Both.
3.
Both can be heard
Can
now.
now. Okay. Yay.
And
Okay. Well.
that's much better.
So thank you very much for
both now?
your
Is it
patience
both are
the getting
you can
the
hear
volcano
both of
show
us?
started. Testing.
Oh,
This is a
brilliant.
volcano show.
Both.
Maanyaa.
Yes, this is a volcano show. Okay, thank you everyone for coming. Last time we almost had a show from Madam Pele, and we missed it just by skin of a hair because obviously it's Madam Pele. And hopefully, so this time I think so we have a lot to share. A lot happened since then, and we also had predictions from last time, so we'll talk about those also today. But thank you everyone for coming. And Landon, I will hand it over
Yes.
to you. What you got for us?
Okay, so well, good morning, good afternoon, or good evening, depending on your time zone and latitude. And thank you for showing up on this volcano show. Here we talk about volcanoes, and we specifically spend a little time talking about what's going on with the Kilauea volcano in Hawaii. And the thing that is we say for the people who are new to this particular show is our planet is a wiggly wobbly volcanic planet, lots and lots of volcanoes. And if we look at the current list of volcanoes, and there's a definition about what constitutes erupting, right? But we're talking about ones that have major eruptions where lava is coming out. In the European Atlantic Ocean area, we have the two perennials, Stromboli and Etna. Now, Etna last time was not erupting, but is under rest, and now is actually erupting again. Nothing in Iceland. And in Africa, you have the usual one where lava is coming out. Africa's being torn in two, so we have the depression in Ethiopia. You have Barren Island in the Indian Ocean. DR Congo has two volcanoes that are erupting. Indonesia leads the world country with 8 erupting volcanoes at the moment. And if we look at other places, the United States, the Great Siskin and one of the things in the peninsula is under unrest that may have changed, and we'll see in just a moment. Central America, of course, the perpetual one in central Mexico that's erupting, the 2 in Guatemala and 1 in Nicaragua. South America, we have Colombia, 2 in Ecuador, Peru, and then we have 2 that are on the Chilean, Argentinian border on the Andes peak. Down south, we have the Sandwich Islands that have been erupting for quite a while, and of course Mount Erebus, which is almost in continuous eruption and continues to be that way. They're counting Kilauea as being erupting there. We have a new entry in the Admiralty Islands in the Bismarck Volcanic province in Papua New Guinea, a new one on the Titan Ridge, and the old one that's been going in Papua New Guinea. Actually 2 in Papua. So Papua New Guinea actually has 3 right now. Solomon Islands, Vanuatu, Tonga, Tana. Vanuatu actually has 2 erupting. Russia currently has 5, and Japan has 2, and Philippines have 2. Actually 2 in Papua. So Papua New Guinea actually has 3 right now. So there's lots of volcanoes there. Solomon Islands, and the list of major eruptions right now. We actually have had some new things right now. There are 2 ones in the United States, Maanyaa and the active volcanic complex in Lucian Ridge Arc that have new eruptive activity. We'll see how will they go. They're currently in rest, and we'll see whether they go into full scale stuff. Of course, Etna restarted. Krakatoa has started again. You might know it has a famous history of big eruptions. And you can see down the road of various things, and of course, Great Siskin is another one that has continuous erupting activity. So these are the ones that are kind of that major, that listed the major volcanoes. So lots of volcanoes, of which Kilauea is one of them. And speaking of Kilauea, right now, there is not lava coming out at this time. We did have an episode 51 and 52. What do you mean by episode? Well, starting on Christmas Eve 2024, Kilauea on the Big Island of Hawaii entered into a new eruptive pattern where it has these episodes. It has these fountains that last for maybe 6 to 12 hours, and the periods of time of the fountains can be between 2 weeks and 4 weeks. And so it has all these episodes.
Yeah.
Yes.
Landon, can you make it a little? Can you magnify it a bit for us?
Yes. Let's do that. Let's do some magnification here. Is that a little better?
Let me just check that for you.
So we're expecting episode 52 to start sometime between about 2 days and between the 26th and 30th on Hawaii time. So we had episode 50 and 51, and we're expecting episode 52 to come within maybe day and a half to maybe 4 days or so. We certainly have had some things. The output of the sulfur dioxide, which is one of the indicators, has ranged from about 1,000 to 5,000 tons per day. It's actually varied quite a bit since the eruption ended. And one thing we look at, so the gas is important because that tells you where in the magmatic column that things are boiling. By that meaning, under pressure down deep, the gases are so much under pressure that they've turned to liquid. But as things rise to the surface, the pressure drops and those gases boil. And when they boil, pops bubbles. Those bubbles give the magma loft and creates. It's the reason why magma comes to the surface and becomes lava. We also look at the tilt meters. Now, in this tilt meter, what we're seeing here, let's look at this one here. This is a tilt meter, and if we look at this set, let me magnify it just a bit.
Yeah, thank you.
So this is the past week, and this scale here is a microradian, 2 microradians. So what is a microradian? Well, if you have a bar that's 1 kilometer long and you lift up a bar 1 millimeter, about a thickness of a dime, US dime coin, it'll tilt about 1 microradian. So we're talking about tiny tilts, but over the last couple of days, we see that this blue line, which is near the summit, near the Halumau vent, rising. When we look at the past 3 months, we see this sort of sawtooth pattern. When the blue line drops is when there's a fountain. So imagine the pressure is building. The mountain is. I'm sorry. The mountain is expanding.
Yeah.
Let me prevent that from happening.
Yeah. Before you know it, the whole system decides to restart.
The mountain has expanded, and it reaches a pressure peak where the boiling reaches the surface. The fountain shoots out, and the pressure releases the steam valve, and the mountain collapses in. If we look at over the past year, we see these patterns. And there's a period of time where they were coming almost once a month. Another period of time they're coming once a week. One thing to look at from this from the episode 51. So here is episode 50 right here, and this is episode 51, and we see that this lead up to it was actually quite wobbly. Instead of having a steady pressure build, bang, it was a kind of up, down, not like you had deflation, inflation events kind of coming there. Watching this one here, when we were sure that it's going to erupt about here, because you look at these things, they kind of hit sort of the same spot, although not exactly before they erupt, but it kind of took a little turn. And we see that even now we have this little turn, this little dip, right? If we look at the set right now, it's been climbing over days, it's reached a peak, it's gone back down a little bit. So these little up-down dips tend to say that they're so. if it hadn't done the dip, it quite possibly could have been erupting during our show. But Madam Pele decided, Maanyaa's in charge. Let me throw a wrench.
So if I might say, I can see that this particular graph that we have on the screen right now, it says past 3 months, yeah? And
yes.
So the one above it is a snapshot of the right at the end, I guess. That's what it is?
Yeah, this is the past week.
Yeah, so that's the end of the, that's the snapshot of the end of the graph that's below for the past 3 months, right on the right-hand side, right?
Yes. These are the two same things. They all end at the same day. That is now, right?
But you could say the one above it, it's kind of magnified for over past few days. So
yeah, because we're seeing this section
section expanded. Yeah. Okay. Magnified. Yeah.
That green line is farther down on the east ridge where Pu'o used to be, where I had the great 35-year eruption. That's why there's siltmeters down there looking down the line. We do see these little wiggles, right? And what happened here, there was a major earthquake in the world, and the seismic waves went through Kilauea and shook it, and that kind of, it's like you've got this beer or soda foam that you kind of give a little shake and it kind of fooms, and that's what these little pulses are usually seismic waves going through the mountain, causing a little bit of a right? It gives it a little, or like you have a barometer, you give it a tap and it kind of settles to the spot. This is showing the year here for that, and so you can see again, we get periods of time, not always at the same level, but kind of similar spots, nor the green line, because that's farther down the ridge, and sometimes they're just a steady rise, and sometimes there's a wobbly rise, and we seem to be in the wobbly phase, which causes the one of the effects is that the actual fountain occurs a little bit later than we might expect otherwise.
So the wobbly phase, if I might ask.
Yes.
So the wobbly phase, does that happen because of the amount of gas that's in the system, the amount of magma that's in the system, or is it because of the changes in the physical, like the tunnel system or the pipe systems of the volcanic structure? Why is the wobbling there?
Excellent question, Maanyaa, and probably the answer is a combination of all the things you mentioned.
All the things. Okay.
There are, and we'll see someone in terms of some of the eruptive fountains. There's been some shape changes. There's been some behavioral changes into the eruption phase. Not major. We're still having these episodes, but they're, and the magma hasn't moved down the other spine. It's still at the summit, but for other reason, the pressure of the magma chamber, if our model is reasonably correct, there's a magma chamber about 1 kilometer below the main vent, which is usually the fresh source of material that launches up into a fountain. We believe the top of that magma chamber right now is there's a foam. Like imagine you've got a keg of beer with a bunch of foam on top.
Mm-hmm.
And
that's the gas,
and the gases are sulfur dioxide, water, carbon dioxide, various gases that are boiling at various pressure levels. You've got another magma chamber that's about 6 to 7 kilometers deep that is below and a little bit to the south that's feeding up into it. So you have these kind of chambers, and that gets from pipes deeper in the mantle where the hot spot hits the bottom of the mantle, maybe 30 to 40 kilometers below. So I get this chain of stuff moving up, and mostly what you're seeing at the surface, these tilt stuff, is due to the top chambers pushing on the rock. They're going to have the most effect on the surface, causing them to tilt. This graph I'm showing you right now goes back to Christmas Eve 2024. So these are this is showing essentially the 51 fountains that have occurred. Every little down drop is when the magma is launched, and as a result, the pressure drops and the mountain sags in, further pushing the the magma into lava on the surface. And you can see that the tops of them have varied a bit. I mean, certainly at the very start when it went up quite high. The tops vary, and there's a period of time where the fountains were quite rapid, and a period of time where they were sparsing out. And here they're kind of, I don't know, they're kind of average except for the wobbly bits.
Yeah, the wobbly.
That's a technical term.
Wobbly bits. Madam Pele
yeah,
dancing.
but Maanyaa, you correctly identified things that are contributing to the physical changes, pressure changes, gas compositions, and physical changes to the system that's leading to this. That sort of. Now, if you look at this graph here, is a different one. This shows the elevation of the floor of the holy magma, the lava that the lava is pouring into, and we can see these jumps. And the reason why they're jumps is that you get a fountain that puts lava on the floor, and the floor rises. So there is these kind of spots here where the things are quite wobbly, is because there's fountains and stuff is flying around, and so the laser ranges gets confused. But you can kind of tell that the floor, when you have an eruption for a while, it kind of sometimes sags down as material comes on top, but then as more material comes on top, the floor rises. The scalar here is in meters, so each one of these little bars are 10 meters. That's about 30 or so feet. And so you can see that the floor has been steadily rising. This is a period about the past year, and you can see that the floor has risen from about 472 meters to about 500 and I would say maybe 515 meters. It's risen quite a bit. Combination of lava on the top and pressure underneath. Here is a map of the eruption summit. You can look down here to see the scale, 300 meters, 1,000 feet. So you can see that this area here where the lava is pouring all around, in this area here, this colored area, shows you where the lava is pouring into in this pit. This pit occurred when, at the end of the 35.5-year Great Eruption phase, a cubic kilometer of magma moved all the way, you look at this little inset here, moved all the way from the summit all the way to the edge of the island and poured out in a huge eruption at the end, causing a hole at the top of the summit. The summit fell in. The summit collapsed almost halfway to sea level. Look at this graph down here. If you can see that, I can magnify it. This graph shows you the side graph, right? And before, at the end of the collapse, when the cubic kilometer of magma moved down and erupted, it fell more than 500 meters, more than 1,640 feet down. This pit occurred, and since then we've had these eruptions, and the level gets higher and higher and higher. Right now, for example, the present day eruption, due to all these fountains, has it filled up 490 meters, meaning that there's about this gray line here. You see this gray line on the top? That's where it was before the collapse. We're at a stage now where the current level is almost consistent with the previous collapse. It went down 500 meters in 2018. Right now it's filled in 490 on average out of those 500 meters. It has filled this volume of lava an amazing amount. And here we're talking about over 284 million cubic meters.
That's how many megapints?
Well, let's see. A pint is about a liter, and there are 1,000 liters in a cubic meter. So this would be 280 billion liters. So it'd be 280,000 megapints.
That's a lot.
If you have a court hearing and you're under testimony, you can use that number as a But again, look at the
if you
you know,
attend
so
your
so
hearing,
yeah so yeah. Assuming you assuming you know what court hearings are. But notice the yellow line over here is getting near the rinse because if you
yeah.
look at this gray line, you see the edge of the caldera where people can go, and you see that this yellow line is getting up near that top, and we'll see it's the vent on the side. Here are the peaks there are getting so high that they're getting to the point of being actually going above that rim.
And they're creeping
Um,
up.
and yeah, so going from this orange line to the yellow line is what has happened with these episodic eruptions. Right? The 51 episodes have filled in all this material, and you look at the volume. There's a lot of volume here that's come out in this thing because these are putting out enormous volumes of lava that have slowly been filling up this set. Now, understand when it reaches the top here, what we're talking about is reaching this level here where it's still got several kilometers of caldera to fill in. So it can drain down here and slosh around just fine. It'll be a nice thing for a tourist show. When you go to the park, you come to the visitor center and Volcano House here. There's a drive you can go along at various vista points and see and look at things. You'll see some pictures of people looking at it quite safely around the spot. So there's some pretty good viewing areas. And in this region here, from the late to mid 1800s to the early 1900s, this is sort of awash in lava. So it's returning back to those phases. This is not a uncommon thing. The fountains are quite unusual in terms of the number of fountains there, though if you hear about the Hawaiians visiting this place in like the 16th century, 17th century, 18th century, they talk about having fountains, seeing fountains and other things there. So it may be returning back to a pattern that filled in. This entire caldera had a major collapse in 1790, and it used to be that this set here, which is this little drop down here, this drop here was about 4 times deeper. It used to be much deeper, and it's filled in quite rapidly. Again, I'm going to impress on you. Normally, we talk about geologic time, and things take their time. Madam Pele has done, in a couple of years since the 2018 collapse, filled in a lot of stuff quite quickly. She's wasted no time in putting on a show. Any comments before?
If we go, okay, so that's the crater floor elevation.
I'm sorry.
Yeah, if we go down again.
Yes.
Yeah. So the yellow line is 2024, is it? Or is it 2026?
Yeah, the current 2024 to now, right? The yellow line is the current eruption phase. So it went from the orange yellow line starting in December 2024 to date. So this
that's a lot of lava to fill up. Yeah.
Yeah, and since December 2024, it is amazing amount of material that's coming out of this volcano.
Yes, that's what I'm wondering. Like, did another vent open up, or is it the same? Those are the same chambers and vents that are feeding into it. Because it's a lot.
There was a little bit of a side thing over here for one of the eruption vents had a little side crack here, but mostly it's been coming out since December 24 out of these 2 vents here, which is really odd because it's doing a lot of work. The magma, so remember that if you look at this meters, right, the magma chamber is probably down where this paragraph is down here, right?
Yeah.
That's where most of the magma chamber sits, and it's got obviously cracks that are coming along this edge of the rock and coming out here, right? It's basically working its way here, working a lot of hard through a very narrow open, which is why you get these really tall fountains. Yeah. And we're quite puzzled. And you say, what do you mean by that? Well, if you look at this inset here, this is the corner of the big island. You have the two spines. Shield volcanoes have spines, and most of the eruptions occur along the east rift zone or the southwest rift zone.
Yeah.
Remember, for those that have been with our volcano show, we had a southwest rift eruption that lasted for about half a day.
Yeah.
In 2024.
Yeah.
We had a east rift zone that lasted for about 7 days. Just a couple of months before this episodic starts. So it isn't as if the Madam Pele's connection to these pipes going downhill has been cut off. It was doing it in mid-2024. She just seems to be saying, I want to push it up the side and put on a show. As I said, when say her dance, she has decided, I'm going to dance here. Got an issue with that?
Oh, heck no. Heck no. Okay.
There was another thing that happened, and we'll see for this episode 51. There was an international hula festival where people from all over Polynesia, from New Zealand, from Easter Island, from other places there, came to this spot where you had the masters of the hula, and they were teaching hula dances in sort of this area here. And some of the Hawaiian hula is about paying respects to Madam Pele and kind of convince her to be calm and to not get so excited and to stay in her house and chill out, because she's pissed off at her sister, the goddess of the ocean. They're both in love, according to the Hawaiian legends, with the same dude that's a volcano god down the Hawaiian chain, and they get kind of they're sisters. They like each other, but they also don't like each other. If you can understand that, Maanyaa, I don't know if that makes sense to you or not.
That makes sense. Smitty asked from the live chat, how commonly is the name Easter Island used on Rapa Nui itself?
It is interchangeable, right? So there is the Spanish term that you'll see in Valparaiso for Easter Island. There's the English name, and the Rapa Nui refer to it as Rapa Nui. So it kind of depends on who you're talking to. Most people understand when I say Easter Island as opposed to Rapa Nui. So as I say, they had a nice festival there where they're having the masters teaching the Hawaiian version of hula with people coming from all over Polynesia, and Madam Pele put on a glorious show.
Oh.
While they're doing the hula, so it was like a really magical thing. People were quite pleased that she put on a show, and they got to do the volcano dance stuff. It was quite a crowd. Let me also talk about the floor elevation over a longer period of time. If you look at this was a GPS meter, and you can see it going up and down, bouncing around in part. This is farther back where these eruptions cause the floor to rise and fall depending upon pressures. And we can see from seismic data, we see that there's a number of earthquakes. Now the color is showing depth.
Yeah.
So blue is much deeper than the. If you look at here's the scale of the chart of the depths down here, and we can see that most of the earthquakes are along this line. Here's the summit right up here. There are not very many quakes up the summit. You say, well, why is that? Well, Madam Pele doesn't have to break a lot of rocks to send magma up the hole, right? These earthquakes are because the weight that's been putting pressure on the top of the summit is pushing the island towards the ocean. The island is sagging in towards the ocean.
It's that much pressure, eh? That it's pushing.
Yeah, but you can see underneath there's been some major landslides into the ocean. And by landslides in the ocean, we're meaning major tsunamis that have occurred from this stuff giving way. Now, it might not happen in our lifetime, but there's all these cracks and so forth, and things can slide in and create stuff. So this is what these earthquakes here are not magma. They're epicenters for stuff. And you can see from the depth, there's a constant depth around 30 to 40 kilometers, things over the period of the last week or so. And these earthquakes, these deep earthquakes, which come from this zone here, is the stuff coming from deep in the mantle up toward, this is the hot spot, hitting the bottom of the oceanic plate. And these are more of the sagging things. So we don't see much earthquakes at the top, and we're seeing material still coming up from the bottom.
So if I may ask the question about the crater floor elevation.
Sure.
Like the tilt meter tells us the pressure that's building or releasing, and the crater floor elevation, does it tells us how much the volcano has physically filled the crater with new lava? Is that what it is about?
Well, this is farther back. This particular spot here is a bit farther back than the pit, right? They've got this GPS meter. They can't put it in the pit because the pit fills up with lava. So you wouldn't get much. So it's a reading farther back in the set. I believe if we go back to, this is showing you, this one graph shows you in the pit where you've got lava. They've got a laser range bouncing off of the rock down there, and it shows you how that stuff is filling up. This one here is farther back. So if we look at the map here, there's a GPS meter that's farther back here.
Okay, understood.
It's away from, because this is getting filled with lava. You can't, you don't really want to put. So they have basically a laser range bouncing off the floor here to get that other one graph, right? This is the laser range here. This one is farther back.
Down. Okay, understood.
Yeah.
Okay, got it.
Great question. Now, that was a past week. So you look at the past week with earthquakes, right?
Yeah.
And you see this thing. This is showing you the time thing here. If you look at the past month, we see a different thing. We see there was a burst of quakes up near the summit.
Oh wow, that's a lot. That's wow.
And so if you look at the depth, right? Let's look at the depth here, right? We still have this continuous, thing from 30, 40 kilometers coming up, and we have a lot of this popping that's occurring
near the surface,
at the summit and a little bit south of the summit. The interpretation is that the lower magma chamber, the one that's 6 to 7 kilometers deep, that's a little bit south of Holy Mountain. So by that meaning, if we go back to the map here, let's go where the map. Here's the vent, and the magma chamber is below this vent. There's another deeper magma chamber that's down here.
Yeah, got it.
Somewhere in this area. And why do you see it to this area? Because in this area, it's sinking in. We've got earthquakes. A lot of these earthquakes that we're seeing, that pile of stuff here, is because the ground is sinking in. Why is it sinking in? Well, the amount of material that's coming up, look at all these earthquakes from the rising stuff hitting the bottom of the oceanic plate that's causing all of these things. The amount of material coming up, and averages, if you average over time, and it's averaged over many years, averages about 3.5 cubic meters a second of magma that's rising, hitting the bottom of the oceanic plate. Yes, a second. That's kind of the rate. Obviously, it varies, but that's kind of the rate. And there are some big earthquakes. I mean, we get some magnitude 4s down there as well. So there's some big things happening in the 30 to 40 kilometer range. The amount of material coming out at the top we can measure because we can see. There's about 6.5 on, even though it's very bursty. On that, remember if we go back to the graph, we see something that looks, we see the very bouncy graph, right? Where is it again? We see this bouncy graph. So it's only erupting during these like 12-hour periods. But averaged over this time, over a couple of years, it's about 6.5 cubic meters a second. So think about this. We've got 3.5 cubic meters a second coming from up on the mantle pretty consistently. How do we know consistently? Because we can see the earthquakes, consistent earthquakes rising from there. This is pretty common there. And we can see the rate. Why is it? Earthquake means rock and the bottom is being cracked, materials working its way up. We know what's coming out the top. About twice as much coming out the top is coming from the bottom. So you would think what this would say at some point, this magma chamber that's deeper. Remember again, we have the summit here. We go back to this map, right? We've got this summit where we've got the one magma chamber is about a kilometer below these vents, and then another magma chamber which is down over here is about 6 kilometers. This is where it's sagging in.
So
why is it sagging in? Because it's more is coming out than in. Go ahead.
Yeah, so the one that's like the upper magma chamber, that has 6 cubic meters per second, that's what you're saying? And the one that's
it's coming out 6.5 cubic meters a second coming out on average.
And the one that's below it, that's 3.5 cubic meters per second.
From the bottom, because we can see from the earthquakes hitting the bottom of the mantle.
Okay.
Right. Okay. And that's actually been steady. That 3.5 about 3.5 cubic meters a second has been steady for decades. This has been kind of constant. This is the upwelling from deep in the earth of the hotspot that's created these Hawaiian islands. And we'll talk about it on next volcano show. There's an article that is suggested that the hotspot has gotten a little bit hotter over the past several thousand years. The temperature of the hotspot on average has risen about 150 degrees Celsius. And that surprised people. It's actually getting hotter. The hotspot is getting hotter, but
that's interesting.
The volume is about the same.
Yeah.
Remember, but so if you look at this cross section again, right? The vents are occurring here. So the big fountains are here. There's a magma chamber in this same scale about here. It's about 1 kilometer down. And then there's another magma chamber way down here. It's about 6-7 kilometers to the south, right? Yeah. And there's twice as much coming out as coming in.
Yeah.
So you would think at some point. Go ahead.
So I'm just thinking, like, where is all that extra coming from?
Well, at some point, the lower magma chamber is going to run out of stuff. If more is coming out than in, it's going to collapse, and we see that. Why? Because we see all these earthquakes of the ground sagging in from that lower magma chamber, which is being depleted.
Yeah. So if the magma chamber that's further down, is there an echo? I think so. There's an echo.
Is there?
Yeah, I thought so. Okay.
Good.
Okay, it's not there anymore.
I can make sure.
Yeah, it's not there anymore.
Okay, good.
Okay, so.
What you're saying?
I forgot. What was I saying? Oh my god. Okay, I got it.
You're talking about the magma chamber. Yes, go ahead.
Yes, I was talking about the lower magma chamber, which you're saying that has more coming in. Sorry, not more coming in. Sorry, has more going out than coming in. What happens
out
if
the top
that,
and coming in the bottom?
Yeah, what happens if that collapses? What happens to the upper one?
One would suggest that the eruption would stop. If it no longer has a supply, if it kind of exhausts its lower supply, the lower magma chamber is bigger, it's being fed by the hotspot, and if it collapses, then it's going to take time for the magmatic system to fill it up to get it to push out the top. And if the bottom magma chamber collapses and so it no longer has a nice pipe coming up to the upper magma chamber and out the top, then it has a better chance to go down the spine, right? See all these cracks here, all the spine here, or that spine down here? You would think what would happen is the lower magma chamber collapses, then the volcano will go silent for a little while, months, years, whatever, and then, but there's still stuff coming up from the bottom. It would just take time for that to repressurize. And then the question is, would it continue to try to work its way up the hard way up all those kilometers out to the peak, or would it take an easy road downhill? Remember, this is downhill, right? This is much lower, easier to get to.
Yeah, there's gravity.
Yeah, and one of the things that's confusing is, why is Madam Pele insisting on pushing out the magma to create these great lava fountains? And we'll see these lava fountains in a moment. Don't worry, we've got.
Yeah, we've got the show.
Why is it working hard to fill up this here? And people think, well, at some point that lower magma chamber is going to run out of stuff, unless there's something fundamentally wrong with understanding of the plumbing.
Okay.
Now I'll tell you that before the collapse that created this deep pit, before that happened, this was at this gray line over here, and why is collapsed? Because there was a magma chamber here, and one of the things we know is that the Eruption knows Pele had sinuses, right? The Holy Maanyaa was just small little pit over here. It was only maybe about 200 meters across, right? It was just a small little hole here. And this larger hole occurred because it turned out that there were side magma chambers that it kind of filled in. And that's, with all that stuff shot out towards the end of the east-west zone, this whole thing fell in. So maybe there are other side magma chambers deeper down that we don't know about.
Yeah, that's what I'm thinking.
That keep supplying.
Yeah.
Right.
So, yeah. Look,
so
Madam Pele may have a backup plan, by the looks of it.
Yes. So to say, oh, it's going to happen, it's going to stop, as soon as we understand it, and this is science. That's why we're excited, because we don't understand something and we're learning. That's the exciting thing. You can tell I'm excited about the fact we don't understand something, because this is all the data, which is reasonable, but there's something else going on now.
Yeah.
It could be tomorrow. The fountain starts, and it's a piddly little fountain, and it stops, and she goes silent. Right? To assume she's going to be doing the fountains forever is also wrong. So.
Yeah.
Oh, there. So let's look at what's happening here. So this was the vent from V1 camera to the show.
Don't do it without me. I'm coming. Give me a sec. I'm coming.
I'll wait. I'm coming.
I'm coming.
We'll wait for.
Wait. Okay, there we go. All right, let's go.
Okay, so I took pictures earlier in the day of the camera. Here's at 10 o'clock. We see that the vent here is sending out lots of gas. Right now it's around 5,000 tons of sulfur dioxide. Here, we're not seeing hydrogen burning at this point. That's usually one of the last things when water gets, because high temperature, it breaks water and hydrogen and oxygen.
That's what we saw last time, didn't we? That was a sight.
Yes. Yeah, and at night you can see the blue flame of the hydrogen oxidizing. It with other gases, because there's other gases coming out that causes things. So this is what the H1 V1 looked like at 10 in time. We visit the camera now and see what happens. It's about the same. There's the pit. Here's V2. This is from farther back, and we see. Remember, there's two vents. The main north one here and the south one here, and we can see how much mounded there. Looking farther back, that was in the morning. Let's see what's happening. Oh, it's raining right now in Foggy. So
everything's like
that's why I grabbed these things from earlier. There, V3 cam here. This is the other side, right? And so there's the north vent, and the south vent. And you see how much it's piled up around there versus the rim, and there's stuff farther back. And we look at right now, we can see, yes, you can see that, yeah. So this one, obviously there's more rain on the camera that's front facing. You can still see it's kind of cloudy and misty.
Yeah.
Air quality is still pretty much there. The trade winds send the gas to the south, where people tend to avoid going. Let's look at pictures, but let's look at volcanic pictures. Let's see what's happening.
Ooh.
So we have this nice little they call it advent calendar. These are the fountains from the 1st to the 50th. This one is an older one, so I don't have the one for 51, but you can see the fountains that it's had there, and the shapes and so forth. You can tell sometimes when both fountains, north and south, go. Sometimes there's single fountains, sometimes there's wide fountains and narrow fountains. But it's kind of varied over time with stuff. Here is showing, I believe this is starting of episode 50, where we see the V1 camera and time lapse. So you can see that before, there's little bits of stuff where it kind of dribbles out and flows down, kind of comes and goes, and then it takes off and goes. Yeah. Right?
Oh.
And I zoom back here. This is something that happened. We'll see is this hill is getting so high that sometimes lava goes around the side and it's doing this.
Where's the second vent?
The second vent is, there's 2 vents here, right? Yeah. It's behind over here. This second vent is over here, and and this is an odd thing that when you get a fountain we've seen recently, where the north vent both start glowing. You can see glow here and here, but the north vent is the one that launches the fountain.
Ah, okay.
Now you say, well, wait a minute. If they're both coming from the same spot, why don't they both go?
Yeah, and I asked the same question last time, and maybe one of them might be cheating.
And that's so this other picture is going forward. How are you know that thought? Because that's an important question to ask. So here is the same eruptive event from the V3 camera side, right? And you can see that there's stuff coming here and here, but during this episode 50, a lot of dribbling coming here, but almost nothing. There's a little bit of stuff here, but not much.
Not much, no.
And so it's like, well, why does it squirt out here and not here, and not do both?
Yeah.
By the way, you can see sometimes where you get these dust devils that then blast the camera with rocks. You can see signs of rocks. I guess that you can see the time here is shifting forward. A lot of material coming out. This was a fairly long thing, and then it sort of ended here.
Yeah, the sun looks beautiful in the background. Yeah.
Oh yes, it is gorgeous. There. So this shows you. Remember, I showed you places where you could see. This is one of the spots along the Crater and Drive where crowds can come there and you can look. And so this is showing you what the crowds look like there watching this thing, right? And it's about half a kilometer.
Half a kilometer.
I would say maybe half kilometer to 3/4 kilometer.
Must be still hot, isn't it? Must be still hot, like half a kilometer away.
Whoops! I'm sorry. I was there, but you can see, yes. Because if we look at the other map here, right? Let's go back to the map. So they're actually no, it's more than a kilometer. They're probably about 2 kilometers away. They're probably in this Kile overlook over here, looking about 2 kilometers in. Right. So yeah, they have it again. As you can see from a tourist point of view at the park, you can get a pretty good view.
Yeah.
The stuff is going to the side, so you're not getting rained on. I wanted to show you again. Here is a fountain. This scale here, this particular fountain, reached about 300 plus meters. That's about nearly 1,000 feet.
Oh wow.
Yeah, of this fountain. And notice the mound here, right? So this is we're at the caldera rim, the mound here, and you can see that the material that is coming off the side gets blown back and piles up here. So this mound, which is now higher than the rim, is piling back from the ash, that is the rocks that is super cooled enough to just rain as rocks down here, right? You can see how that this thing is actually rising above the caldera rim from the backscatter of this thing. So and what do you mean by that? Well, here's a picture.
Oh.
And they came back actually when it's not erupting. You can see a cell phone here. This is a lava bomb.
Oh wow.
Now
That's a big lava.
why do we say don't go over here and look at stuff?
Yeah, you get
Besides,
blind.
you get all this glass and things raining on you. You get blobs like this. See, there's the top of the mound. That is this mound right here. So we're this blob hit here. Now, how did it get this far? Well, the direction changed also, and then upward convection. It's got these and these blobs sometimes get, these blobs like here sometimes get, because we look at stuff here, you can see these blobs get carried with you get these glass streamers that give it kind of a loft, and the result is the material goes back and rains down over here. Yeah,
Smitty from the live chat said, lava bomb sounds like something Chesh would mix. And then Aldebaran said from the live chat, on Sean Wilsey's channel, people wondered about how long would it take at this rate to fill the crater. They were also asking about filling the entire Kilauea crater.
So, I mean, the down drop block, as you saw, is getting close to filling, right? There's actually some spots where it is nearly within like 10 meters of flowing onto the main floor.
Yeah.
There still is a lot of volume. So if it keeps going at the rate, it may be about a year before the complete collapse area has completely filled in. And it's now going wider over the, because the bigger caldera is like 3 to 5 kilometers oval, right? And it's going to take a long time, unless Pele says, hold my beer. And says, so I also want to show you that, again, you can see from the scale of the cell phone, the glass, right? You could see, and the person said, this is still hot, right? This fell about a day ago, this large blob, and it still is hot to the touch and has liquid stuff inside. And you can see the glassy, minerally stuff here that's quite there. So these bombs, and there we are. They're called bombs, right? You can see other ones in the distance here, right? When stuff. So that's why they talk about don't go back there, especially during eruption, because these blobs, this thing carried, this blob was way back here from there, right? So yeah, you kind of stay back. You can. What do you see? It's better to be back over here where the tourist zone is, because it's nice and safe. I want to show you as well, during the time on the Northwest Wall, they did an expedition to examine the summit because of this collapse. They could get into, this was on July 2nd, so between stuff here, they were taking samples because the collapse gave them access to this strata.
Oh, okay.
That before, when this was a deep pit, they couldn't get to, because this is a very crumbly wall, right? It's a very unstable wall, but because here they can climb up a little bit to start sampling stuff. This was material that was laid down before the great 1790 summit eruption that changed the Hawaiian political history. And so they wanted to get to these spots here, and the fact that the floor is rising up gives them access to this strata. And of course, they're doing the safety things with hard hats and gas masks and all that good stuff, because they solve all safety protocol. If you look at the Kayan complex, so here again, this is this south vent, north vent, south vent area. You can see the bound, and you can see how much the pile behind it has come from these events. If you look at this spot here, here's showing you the larger stuff. So when you said, how long does it take to fill the caldera floor? Well, it turned out that maybe if things continue to go the rate that they're going, which is a big if, you might see that this zone here, maybe by the end of the year, has filled in most of the collapse. Remember, this used to be a hole that was about more than 500 meters, 600 feet deep, that's filled in since 2018, and the big part of it came in these last 2 years. So this is a larger caldera floor, right? So this is the 3x5. This larger pit here is the main caldera. That's 3 by 5 kilometers wide. There's an observation spot here, and the volcano house is over here. So this zone here is going to take much more time. When the 1790 eruption occurred that formed this caldera, the caldera is about 4 times deeper than it is today. This floor here kind of had its last big eruptions around 1909 when lava was really pouring in along this area back here. So we're getting to the point where this is going to start filling in. Now you see there's a little sign there. So, but remember, it's been taking 1790 for this to fill up 3/4 of the way. So, and remember that stubborn lower magma chamber has more coming out of it than in, unless we don't understand something, which would say that this eruptive phase, if has to kind of end at some point and go into a period of quiet, but we'll see. Because obviously there's something going on that we don't quite understand. Here's another picture. Go ahead. Yeah.
Aldebaran from the light chat said, I walked along Waldron Ledge. I love that spot.
It is an amazing place. That is, and the plants and ferns there, you understand why it's called Halit Ma'ubau, which means the house of ferns. Because that used to be a nice, gentle dome that before the pit occurred, it'd be a nice little rounded dome with a small hole. And there were lots of ferns around that area, right? Suggesting that for a long time, Kilauea had this kind of gentle vent at the top, and the thing fell in. This giant caldera pit formed 1790, and this used to be 4 times deeper than it is now, this ledge. So between 1790 and 1909, this filled in. This thing collapsed in 2018, halfway to sea level, and it's filled in mostly by this time. But there's lots of great trails around here. Stay on the trails. Don't go to the edge.
Yeah.
Don't be stupid. Because this side here is crumbly, but the park has staked out really safe places along the way, and there's great views, and I would highly recommend that. So I'm going to show you what's happening here. So I would look at this picture. So here's the old volcano museum that had to be abandoned because of earthquakes. You could see the rim. You could see here's the vent, and you could see how the pile, the cone in the back is now getting higher than the rim. From here to here is now the old caldera, where this is nearly at the full mark for the original pit that collapsed. Here is something that's happening. So this is a drone view looking down the south vent. And what do we see?
Oh, wow.
We see a lava lake. This is July 14th. This is not during an eruption.
Oh, wow.
This is how close the top of the magma chamber is. You got this hole that's releasing gas, and you can see there's a bit of stuff going on. And so you say, well, wait a minute, wait. The north vent's where these big fountains have been occurring the last couple of times. Why isn't there a fountain here in the south vent? It's got this hole. The magma chamber's that high. Yeah. Good question. Here's a north vent. At the same day, they looked at the north vent. You can see that there's a lot of churning on the north vent, although the hole is smaller, although there's some cracks in here. That's the north vent. So there's a south vent, a little bit deeper, a little bit wider, but no fountains. North vent where the fountains occur that launch out of that hole. By fountain, what do you mean by this? Well, here's a fountain. This is episode 51 fountain.
Wow. Oh wow.
Right. And she was, again, the height here is about 300 meters, about 1,000 feet here.
Oh, wow.
You can see a lot of ash. There's that mound that we talked about, where you can see this one, the vent is going back farther, right? There's a lot more material going backwards than that. The 50 was kind of forward. This one's kind of back in there. There's another one showing you that the thing was angled such that we got a lot of stuff going back.
Yeah.
And around the side.
Holy moly.
And I want to show you, this is a time lapse. I believe this is probably V3. We'll see the time lapse of episode 51. So it kind of was dribble stuff. We thought, is it going to start? Is it going to start? Is it going to start? Well, maybe not, maybe. Oh, there it is. It's starting, but it's kind of dribbling, and then it pours, and we can see this. See, this is fresh lava right here. You can see the lava coming out here, right? And look, it's reached all the way back to here now. This is flowed out along this edge. That back channel was a channel going this way. You can see, look how fast it is filling in.
Wow.
Look how fast that material went all the way across that floor.
And then
and of course at night you can see all the glowy bits there.
Glowy bits, yeah. Wow.
Yeah, that's a technical term. So when we talk about size, this is scale at 300 meters. We were looking at this entire pit filling with material.
Yeah.
Right? From that camera, going back to here, right? When it went towards the edge, when you see this material coming out, even though the fountain's not high, but the volume is enormous. During that period, even though the fountain was not high, the volume exceeded about 650 cubic meters a second.
Wow.
And so you see all the glow material that wrenched across the spot here. And again, some of those spots is only about 10 meters to the old caldera floor. Here's another one from V1, and we'll watch this happening. You can see there's plenty of glow on the south thing, but it's a north one that launches this outflow. And it dribbled for quite a while with small fountain, and then the pressure rose, and then it took off, and then you can see the back splatter and the backward direction, that it was going kind of backwards rather than forwards and around the edge. And it was, even when the fountain height went down, there still was enormous volume coming out. So it's not, it's only 100 meters, and even here there's a volume coming out. You can see that the lava kind of heading downhill. Let's look at another one here, another camera showing you the other side of the eruption. You can see that the day thing, again, you got these on again, off again things with these little lava bits coming out. Even though it's fountain's not there, you can see the lava heading across and then surging, huge surge at the backside and a huge surge around here, and another huge volume.
It shifted a lot of material too, isn't it?
Yes.
Flow was that good.
And so you can see that some of the stuff back here is pretty close to the old kind, and at another fountain, even though it was a lot of material, the fountain wasn't high, but a lot of material came out on the side. So I want to show you, here was, this shows you the drop block from episode 49, and I don't know if you can see their old road. The old people that probably went a long time went around the edge, like that person was talking about hiking. You probably went along the old Crater Rim Road. That's the road there. This was at 49. This is what the road looked like at 50. There's a road there, and then 51. You can see the old Park Road, and it's kind of, I think, in pretty short order, this old Park Road will be covered by lava from. This is from episode 51. You can see from 50, 51. There's a lot of material piling up. Just about Kings there, another one to look at. You can see, again, the result of 51 and these big flows heading off to the side, piling up ash behind it, and so forth. So that is the kind of the set for what Madam Pele is doing.
Okay, so we could go to the predictions from last episode and see who got
Yes,
what.
please. Yes.
So let's see. Athens had said whatever Landon's is, it is usually correct.
Well, yeah. We'll see how well.
Someone had said.
So we had two fountains.
Oh, okay. Landon, you had said
51.
episode 50 happening live, then 2 more episodes, likely 51 and 52 before the next monthly show. Similar height around 200 meters, duration 7 to 9 hours, volume around 5 to 6 million meter cube, roughly 14-day intervals.
So there's a bit of, yes, we had a 50 and 51, but 52 has been delayed, right?
Yeah, delayed, yeah.
This little down thing here meant that we would have likely have had 52 happening now if it didn't have this pullback here.
So
Madam Pele says, Cheshire's running the show. Let me mess with her. But yes. So I would say that 2 to 3. The heights. I'll look at the heights here for just a moment to get the materials.
You said around 200 meters.
Yeah, and I think if we have the set here, I'm looking for the spot. I'm looking for the height stuff here. So continue with the other thing, and I'll get that data about the height.
Okay. Orange Dot had said 300-meter fountain 3 times. So they were right on the height, I guess. They were closest.
They're right on height. They're right on the height, but and if she hadn't had the pullback, they might have been right on the fountains. So pretty close.
Yeah. Mine.
Again.
Go on. Yes.
They're expecting episode 52 to occur sometime. They're suggesting sometime between July 26th and July 30th.
Okay. All right.
So.
And I had said after episode 50, 2 more proper fountaning episodes, and they will probably start 1 or 2 weeks later. And I had said that north wind will do the main work, south wind will glow, spit, and act dramatic. And the height I had mentioned.
Spot on.
Yeah. And then the height I had said was 170 to 260 meters, which I got wrong. And volume I had said 4 to 4.5 million meter cube. That's what I had said. You had said 5 to 6. I had said 4 to 4.5. How much did Madam Pele give us?
It's closer to 5 to 6 on those things. You got to average them.
You were right about the volume.
Yeah.
And you had also said, I think so, something like, because I had said the height will be lower. No, I had said the volume would be lower. So you would have said that, you had said that if it was low volume, that the duration would be shorter, but we saw the duration was for quite some time, if I'm not wrong.
Yeah.
Yeah.
I'm looking to see the other data here. Yeah. Yes, please continue. I think the thing that we missed was the assumption that they would have 3 fountains by the show, but it turned out no, we had 2 and almost, right. And we're gonna miss because it's not like tomorrow. It's probably going to be 2 to 6 days from now, maybe.
Yeah, and so do you want to make a prediction for the next one, Landon?
Okay. Yes. So looking at the spot here, so we'll have episode 52 will happen next week.
Okay.
And they seem to have. So I believe that we'll have an episode 52 and episode 53. So when is the next? We're talking about a month from now. We're talking about what's happening in the next month, right? We're going to have a Volcano show a month from now.
Yeah.
So I would say we'll have 2 episodes. 52 and then 53.
Okay.
And their heights will be probably in the 200 to 300 meter range.
Okay.
And that the volumes will be similar to what we saw in episode 50-51.
Okay, similar.
So we're kind of like, it's like saying, we're in this period where we had this fountain and this fountain.
Yeah.
It'll occur here, and then we'll have our show.
Yeah. Orange Dot from the live chat said, I don't try to predict volume for good reason. Sure, yeah.
Yes.
Yeah. Well,
Smart.
Madam Pele is like, do you really want to go there? Okay, let me see. Here, take some more. Anyone else in the live chat who want to make predictions before I give mine, and then we close off the episode? Anyone? No?
Is there any other things there?
I didn't see any questions. I would.
We did take some questions. Any other questions you have?
Me?
Yes, go ahead.
Yeah, I. It's not really a question. It's like I would like to observe and see how long does the chamber that's like deeper inside the Earth is going to stay without collapsing. I'm more interested in that.
So Smitty has a prediction.
I predict a lady host will eat during the stream instead of before. Oh, okay, I see. Yeah, I ate. I was hungry.
I had a orange Campari vodka mixture.
Ooh, nice. Aldebaran said it will be the north vent only on about Monday. Okay, Megan.
Okay, so we're talking about episode 52. We'll have no fountains out of the south vent, which is pretty consistent. So I think that's a pretty good thing. And you're suggesting it happens on Monday, which is the 27th. So that given if you look at this graph, you say, well, yeah, it's going to be maybe out here, maybe that's I think that's pretty likely.
Yeah. Orange Dot modified their prediction a little bit. They said 3 fountains, 250 meters each. That's what they're saying. And
so so that would happen if it stops doing these
wobbly bits,
pullbacks, and starts to go straight and speed up. And there's something to say, because look at remember the thing about starting dot, because remember when it was doing these wobbly bits and people saying, "Oh, see, it's running out of steam." Excuse magma chamber, more coming out than in. Da 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 da. Ring down, it's slowing down. Da da da. And Madam Pele says, "Hold my beer." Bing 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 bing.
She was like, "Hold my mega pint." Yeah.
So that is a fair assessment to assume that this pattern of wobbly bits is going to continue. It's wobbling now, but the lead up to this next one is not as wobbly as this one, right? The wobbly stuff tends to delay it, and if it only takes a little bit of a dip before coming out again, because some of these dips are shallow before it takes off again.
Yeah.
But this one here just had one dip before it reached the top. So yeah, there's something said for what Orange Dot is suggesting.
I would say there will be. Megan from the live chat had said, "You get a boulder, you get a boulder, you all get a boulder."
Yes, those lava bombs are pretty interesting.
I would say
they're beautiful. The colors didn't do justice there, but they're beautiful. The
and they're
grass
lethal.
and city and stuff.
Yeah.
Well,
Beautiful
afterwards, looking at afterwards.
Yeah.
Yes.
And so I will say we will have episode 52 maybe in 4 days, I would say. In 4 days, we'll have episode 52. Height of the fountain, I would say between 280 to 300 meters. Again, north vent will be doing the work.
Yep.
And I would say, again, I'll go with 4 to 4.5 million meter cube of material. Yeah.
Yeah. Now, what would mess all of these very predictions up that we've made is if the south vent kicks into gear.
I think south vent will go on. Sorry.
So because what we've seen is that the south vent glows.
Yeah.
Which means there is plenty of magma near the surface. It's glowing. You see why it's glowing, because now it's got a lava lake in the south vent is wide enough you can see the lava lake looking down. Remember those pictures we saw looking down on it? Where we're talking about here, right? Where's it back here? We're looking at so there's the north vent. South vent's got glow bits. So this is when you see the glow and gas coming out. You're seeing this thing, and you can tell from look at this rock. This level is not risen up here. This is not spilled out. You've got old material that's fallen into it, not coated.
Yeah.
Where the north vent has got all kinds of material because it's stuff doing the work. Why little comes out here and lot comes out here, and they're just quite near each other. I mean, there's the north, the south vent's behind here. Why? I don't understand the plumbing.
Yeah, the plumbing. I'm also a little confused. Either that thing is blocked, or it's getting lava from somewhere else.
Yeah.
So
there's something wrong with our understanding.
It's not consistent with the with the north vent. Yeah. So there's something different going on with a different system. So either it's blocked.
Something wrong with our understanding.
Yeah.
Pele knows what she's doing.
Yeah, Madam Pele is like, let me give you a little puzzle to work your brains with. Here you go.
So we thank you very much for tuning in and hearing us being puzzled by stuff. This is how science goes. You are consistently there. You're getting to see the rhythms. There'll come a time when we have episodes, a number of months of episodes, and there's no lava to look at. So enjoy the fact that we've got all these shows here, because Madam Pele is entertaining us. But there will be a period of time where she won't be loving, right?
Yeah.
But until then,
we will enjoy.
Stay with the rhythm.
Yeah. Okay. All right. So, anyone last words, or else we'll just head out. And yeah, thank you for coming. Thank you for enjoying with us. And yeah, everyone have a good day, good afternoon, good morning, good evening.
Thank you.
Your time zone, wherever you're
Bye.
from. Thanks a lot. Bye.
Bye. Bye.
Give me a sec.
Thank you.
Yeah, no worries. Just 1 second.